This is the second page of our group work for section 3.4 on the chain rule. On the bottom of the first page, you already did a problem that involved both the product rule and the chain rule. Here we need both the chain rule and the quotient rule, and it is in that order. First and foremost, there's an inside function and then an outside function, which is the sixth power. So that is chain rule. So we take the derivative of the outside function by bringing down the power, leaving the inside alone, subtracting 1 from the power, and then multiplying by the derivative of the inside. Then it just so happens that the inside function is a quotient with x's on the top and the bottom, requiring the quotient rule. So we just recopy everything we've already done, and now we need to do the quotient rule on just the inside, which is the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. I don't make you simplify these, so that's a perfectly fine final answer. In the next problem, you can see we have yet another equation of the tangent line problem, and we're just showing that the process does not change, it's just what kind of derivative rules you need might change. So I always use the original function to find my y, so I plug 2 in the given x into my function, then I get 36, so I have the point 236. I always use the derivative to find my slope. So first I have to find the derivative using the chain rule. I take the derivative of the outside, which is me bringing the 2 down, leave the inside alone, subtract 1 from the power, leaving me a 1 power, which I don't have to write, but I wanted to show you what I did. And then I multiply by the derivative of the inside, which would be 3x squared. This, of course, is not a slope. A slope is a number. The slope is what we get when we plug 2 into that. And when we plug 2 into that derivative, we get 144. And then we simply write the equation of the line. Y minus our y equals our slope times x minus our x. Distribute and add the 36, and we get y equals 144x minus 252. Really, the generic version of the chain rule covers all applications with all inside and outside functions, but because a couple are different enough, it might be worth thinking of them by themselves. So I do have, for instance, e, since e is its own derivative, the derivative of e to a function is itself times the derivative of its exponent, because its exponent is its inside. Or, oops, this should be an a, sorry for calling our base a. The derivative of something other than e raised to a function, so any base a raised to a function of x, is itself times ln of the base times the derivative of that exponent. Also, the derivative of natural log is 1 over its inside times the derivative of its inside. So that is just me doing the derivative of the outside function, which is ln. We learned that was 1 over. But, you know, what does it look like specifically for ln? It's 1 over the inside times the derivative of the inside. Or for a log with a different base, again, sorry, these should either both be a's or both be b's. If you have log base a of an inside function, it's 1 over the inside times ln of that base times back up high the derivative of that inside. Again, you don't really have to waste brain space on these. They all follow the derivative of the outside evaluated at the inside times the derivative of the inside rule. But if it helps you to know what it looks like for some of those special cases, I wanted to provide it. So then our last example. Down here, here's some examples using those. So if we have 5 raised to a function of x, the derivative is itself times ln of the base times the derivative of its inside, which is the derivative of its exponent. Here we have an inside function, e to the x plus 2x raised to an outside function 5. So the derivative of the outside is to bring down the power, leave the inside alone, and subtract 1 from the power. And then we multiply by the derivative of the inside, which is e to the x plus 2. Lastly, here's an ln problem. The derivative of ln is 1 over its inside times the derivative of its inside. You do not have to rewrite it as a single fraction, but you'll also often see it written that way, so I wanted to write it both ways for you. I actually prefer the top way because it shows literally the process of the chain rule, that it's 1 over the inside times the derivative of the inside. So that's it for section 3.4 on the chain rule. Do your MyMathLab homework to practice it, and move on to section 3.5, implicit differentiation.